Hi guys, we're going to do the check you understand on page 445. Okay. About 75% of young adult users age 18 to 29 watch online videos. Okay. So is that a parameter for a population or a statistic for a sample? Well, we weren't told of any sample, so that's just a known fact. So that is a population parameter. Okay. A population proportion of 0.75. Now, suppose a sample survey contacts an SRS of 1,000 young adult internet users and calculates the proportion p hat in this sample who watches online videos. So in our SRS of 1,000, if they told us how many people of that 1,000 watch online videos, we could just put that number over 1,000 and get our sample statistic, our sample proportion, p hat, okay? But we don't know that, okay? But knowing the population parameter, we can figure out everything we need to know about the sampling distribution, okay? Okay, so the first thing says, what would be the mean of the sampling distribution of p hat? So if we took every possible sample of size 1,000 from the population of all young adult internet users, we would assume the mean of all my sample proportions would equal the true population parameter of 75% of young adults that use the internet, watch online videos. Okay, so that would be my mean. Okay, we would assume it's going to be equal because we're going to assume that our sample, our multiple SRSs are, or the sampling distribution from our SRS is an unbiased estimator, so they are equal. Okay. Second one says find the standard deviation. So the standard deviation of all the sample proportions, we have to follow this lovely equation, which is p times 1 minus p over sample size. So that is my population parameter, 1 minus, and then over my sample size of 1,000. Throw that in the calculator. Okay. So my standard deviation is actually pretty small. Okay. 1,000 is a good sample size. Now, the only reason I can do this is because my 10% condition is satisfied. Okay, and what that says is my population has to be greater than 10 times my sample size. All right, so is my population of young adult internet users greater than 10 times 1,000? Yeah, I'm pretty sure there's more than 10,000 young adult internet users. Okay, pretty sure there's more than 10,000. Okay. So again, I can't calculate my standard deviation unless I prove the 10% condition rule. Okay, and the 10% condition rule helps us with the issue of as soon as you pull one person out of the population, it should decrease the probability, or the probability should change. But since the population is greater than 10 times the sample size, that change in probability after we take a person out of the sample or out of the population is so negligible it doesn't even matter. Okay, but anyway, just do your 10% rule. 10% rule. Okay, number 3 says, is the sampling distribution of p hat approximately normal? Okay, so in order for us to check for normality, because we want to be able to throw everything on a normal curve and z-score it, okay, find out maybe, the proportion of if our sample has more than 80% internet users that watch online videos, but whatever, we have to check our large counts condition. And that's just that same thing we've seen before. N times p and n times 1 minus p have to be greater than 10. So again, my n is my sample size, and there's my p, so that's what, 750 is definitely greater than 10. And then 1,000 times 0.25, 250, again, is definitely greater than 10. So our large counts condition is satisfied, so we can say the sampling distribution of p hat is approximately normal. I'm going to abbreviate. Okay, since that condition was met. Okay, all right, last thing says, if the sample size was 9,000 rather than 1,000, how would this change the sampling distribution of p hat? Well, let's look up here. If I change this to 9,000, sure, I could just rewrite that into my, I could just change that to 9,000 and recalculate, which I'm going to do. But if you think about it, I would multiply that by 9. And if I square rooted 9, I would get 1/3. If everything else being the same, that would have that 1/3, what am I saying, effect on this. So it would basically cut that down to 1/3. It would be 1/3 of that, okay? So with my new sample size of 9,000, my sampling distribution, my standard deviation of my sampling distribution would be, let's see, 0.0046, okay? Again, I've got to do my 10% condition. Am I pretty sure that there is more than 90,000 young adult internet users? Yeah, definitely. Okay. That's a strange looking E. Okay. So my 10% condition still applies even with my new sample size. So I'm pretty confident with this with this standard deviation. So again, since I multiplied that by 9 and I take the square root of it, it's really just 1/3 of that. So if you put that and take 1/3 of it, it is that. Okay. Not that you can't calculate it independently, but just to show you that relationship. Okay. The rest of my sampling distribution, what would my new mean be with my sample size? The new mean would be exactly the same as it was, okay? Just a little tighter, and we would expect that, okay? It's still, the shape is still going to be approximately normal. Well, I'm saying it is, but let's check our large counts condition because of our large counts. Now, of course, our N has increased. Our sample size has increased, so what's 75% of 9,000? That's 6,750, definitely greater than 10, and then 25% of 9,000 is 2,250. Again, both greater than 10. So my sampling distribution still has the same mean. Standard deviation got a little smaller, a little tighter, which we would expect with a larger sample size, and my shape is still approximately normal because my large count still holds true, okay? Plus, I was able to do my standard deviation because my 10% condition also was still satisfied. Okay, I think that's it for that one. Okay, great. See you for the last one for Chapter 7, coming up next.